In this series of interviews, I'll be discussing with leading IP industry experts their transition to IP and their IP journey. I'll be talking about the challenges they've overcome, the decisions they've made, and their long-term objectives. Geir Borderland is Head of Technology Portfolio for the Norwegian Broadcasting Corporation and will be discussing his Greenfield site. Paul Markham's Director of Media Infrastructure Architects for Discovery and will be talking about software. And Dave Schwartz is Managing Engineer for Diversified and has more IP infrastructures under his belt than any of us would care to imagine. Dave is going to be sharing his knowledge and experience with me. IP is more than just about changing the acronym SDI for IP. It's given us untold flexibility because it's allowing us to move to software processing. Although we've been using software for many years in broadcasting in terms of control, it's only recently that we've been able to process real-time video and audio in software. This flexibility and scalability is untold, and we're only really just starting to uncover many of its great strengths. IP packets in themselves don't care about the data they're transferring or the transport stream they're being transferred across. They're quite happy being transferred across Wi-Fi or Ethernet or any of the other telco standards available. The data they carry they don't have any knowledge of or care of. They could be carrying HDR, WCG, SD2110, 2022-6, NDI, HD, SD, 4K, or anything else we could care to imagine. Fundamentally, the IP packet doesn't care about the data it's transferring. It just sees it as data. And these are two of its greatest strengths. I start by asking Geir to tell me more about his plans. Okay, so what's your main motivation for wanting to go to IP?
Firstly, it looks like a sensible choice when we know that when you look several tens of years into the future, we need to be prepared for new formats, new production forms, and especially also an OTT service that are growing with new services and a lot of new functions all the time.
I've been thinking about IP networks and the demarcation between broadcast and IT. Have you had any more thoughts about this? And I mean, are you going to keep broadcast and IT apart, or do you want to put them together there? I mean, what are your thoughts?
I remember some old cases there. I remember talking to Finnish radio sometimes, which are great colleagues in Helsinki, and I remember one time they had plans for making 5 different networks. But of course, the first thing you start talking about is then connecting these different networks, because you need to have control signals going from one area to the other and so on. Mm-hmm. After that, we have a lot of new tools now with software-defined networks and being able to control it much more. But let's say I'm quite skeptical of forming different networks, because I think the first thing you will start is forming new bridges in between them. But I still think our network people like to look at production and ordinary administrative IT as probably 2 different segments of this. And of course, at least try to secure the flows in the broadcast environment much more than in the administrative kind of more not so linear areas. And I'm a broadcast engineer from background, and I know if you lose bits in the linear world, you are really losing something on air. So we need to secure this world in a good way. Then I think we need more experience really to see how there, and we already have started training and talking a lot to our network people to see how we should do this. But it's very early stage yet.
Have you had any thoughts further on whether you're going to go ST2110 or 2022-6? Have you had any more thoughts on that yet?
I think we would love to utilize all the new possibilities in this. So I think 2110 is probably a wiser choice, but I still also think that it's a lot of interesting issues to look at on, for example, solutions with NDI. So we already have tested NDI in some small sports production, and it worked very fine, and also just recently took a lot of looks on a new solution based on NDI. So this really depends also the bandwidth. And for Norway, we have a quite different situation with our regional office than with our centralized organization. So we also need solutions that can cope with narrow bandwidth, long distances, and also the regionalized situation, and also, of course, with all the different OB and outdoor broadcast situations. So I think we will try to test both solutions with the narrow bandwidth and also with the big drama documentary situations, and of course having bandwidth enough to being able to utilize that. And also I know that because 2110 has a lot of new possibilities with breakout in different sectors, and that this are really packages that you could utilize in different means. I really would love some of the functions in that package. So yeah, you know, today we have a lot of equipment that's resides into our machine rooms that only do, if you want to pick out an audio signal or out of a video signal because it's embedded, you need it to run it through an Axon shelf or of some kind, or a leech system, or any other things you have in to the machine rooms. And every box inside the machine room here costs money. So if you have a more modular, flexible infrastructure in the bottom, we definitely would use that.
Okay, and you think that's what specifically 2110 can bring you, is that level of flexibility?
At least that's one of the things I've seen that it's in the possibility package yet, and I know NDI also have that in their package. So I think we need to test more of this. And I know it's other companies in Europe like VRT and BBC and others that have really done a good sandbox job with IP, and I think we will try to learn a lot from them.
Although NRK have years to go before they start building any infrastructure, they're already thinking about the type of network topologies they're going to use, the switches they want to use, the protocols, whether they're going to go SD2110 or NDI, or even possibly both. There's no technical reason they can't use all of these formats together on an IP network. I think the real innovation for broadcasters in respect of IP networks is that we can future-proof our decisions, and we can future-proof the design, so we don't actually have to make absolute decisions today about the type of protocols we're going to use. And who knows, in 5 years' time, when NRK actually start building and possibly transmitting, a new format altogether will have come along, and they'll want to use that. IP networks give them that flexibility. Broadcasters have always thought in hardware terms. This, I suspect, in part has come about because we've always pushed electronics to its limits. With PAL and NTSC, we were pushing analog electronics to its limits. Then SDI came along and had 270 megabits a second, which at the time I thought was incredible. Then 1.5G came along, 3G, 6G, 12G, and we just seem to be pushing technology to its limits. But the real game changer for broadcasters has been the innovation in other industries. So the innovation in the telecoms industries, the finance and the medical industries. Because what they've done is they've given us COTS servers and software-defined infrastructures and software-defined networks. And I think this is a real game changer for broadcasters. I started by asking Paul, who has migrated an entire radio network to IP some time ago, I hasten to add, how software-defined infrastructures are going to help broadcasters.
I think it's cloud that brought software-defined infrastructure to the world, isn't it? So back then we were, you know, it was pre-config management. We didn't have things like Puppet or Ansible, and we didn't have clouds at that time. What we did do was things like software as a service, and that was quite a pioneering idea at that time. I think the infrastructure was still very much physical data center based, and so it's really the advent of AWS, the advent of virtualization, and all of those things that happened maybe about 10 to 15 years ago that have brought us to where we are today in terms of that software defined infrastructure, in terms of writing those templates that can really literally spin up or spin down an entire data center virtually, which I think is an established way of working in, let's say, simpler IT industries. So if you're running an e-commerce startup or doing something along those lines, you wouldn't even think about using a data center or buying any tin. You would just spin it up using, you'd have your templates and you'd be dynamically controlling your architecture from that. And I think really for IP in the broadcast industry, the instigation of IP is almost the final piece of the puzzle in terms of enabling that whole revolution to happen. And of course, when I say broadcast industry, I probably mean the TV industry or the broadcast TV industry. And so we've got this final piece of the puzzle. So we can now say, well, we don't need baseband to give us the to give us that interconnectivity between devices. We can now use IP, and we can still get the quality and we can still get the latency that we need to run our services. And it's early days just yet, but I think where we're going is into a world of software defined infrastructure.
When you talk about software defined infrastructure, again, this is something relatively new to broadcasters, because having the ability just to spin an entire facility up and then switch it off at the end, it's more than just switching it off, isn't it? It's actually deleting it and then allowing you to use those resources elsewhere. Yeah,
it's spinning it down and doing that cleanly and doing that, I guess, in an automated fashion. And that's a real mindset change, I think, in terms of how we think about the way we do things. And it's going to take some time to really embrace that. There is no doubt that the mechanics of achieving that are not trivial. There's quite a lot of background and implementation to do, and it becomes not just the challenge of doing the thing of covering the event, but the challenge of how you manage the infrastructure before and afterwards.
But there's also this idea of software. So when I think that the whole idea of software is taking on, I hate to use the word a new profession, but that's really how I see it in terms of broadcasting, because it's not a case of just hacking a bit of code and leaving it on a server running and then somebody forgetting what it does and why it's there. I mean, this software we're talking about, these scripts that we have to run, have a life of their own, don't they? They have to, they have to be managed in the same way you'd manage a multi-million-pound project.
And of course, those hardware devices, I'm sure somebody will be thinking, those hardware devices that we've been using for some time have obviously got software in them. And I think the difference is that when you're producing a hardware device with embedded software in it, the software development process is very rigorous, and it ends up with something that then has to last the lifetime of the hardware device. And maybe some devices have firmware updates and some don't, but it's a very different world to the idea that everything is software defined and that updates to the software will come much more frequently, and they have to come much more frequently because somebody's found a security bug or somebody's found an enhancement that people want. So there's this cadence change that it's suddenly, now everything's in software. Now everybody wants improvements faster. And so you've got a speeding up that's going on. And that brings with it a lot of challenges, because if you've got a tested box that's been in a rack and it's been working for 10 years, you've got a lot of confidence in it. That's the thing. Obviously it's not going to last forever, but you know what it's going to do, how it's going to do it. I think the whole way that software is a much more dynamic and much more evolving beast is something that is a challenge to contend with. But fortunately, there are other industries that have been tackling this problem for a very long time, and I think there are methodologies and disciplines and tools out there that have been developed not that they're perfect, but they've been developed to challenge, to solve these challenges with software. And they're things that we have to embrace in order to make a success of this world and embracing this new discipline, as you put it.
Can you talk us through the process of what it means to as we sort of say, spin up an SDN system? What exactly does that mean?
I guess what you would have is a set of templates which defines the networking and defines the components that you want to slot together. And these components would include your software or the software that you've set up and configured. And there's an element of dynamic configuration that might go into that somewhere. So to specify what the channels are called, or what the event's called, and which bits connect to which. But yeah, you would have some sort of template, and you'd spin it into your console, which may be a cloud provider console, or it may be something that's a service provider console, something that's a in-house built console, or it could be all sorts of different things. And then from that, your resources are created in time for the event. So the great thing about live sports is we know when they're going to happen. It's not like we have to anticipate a rush of shoppers for a particular item as you would do on an e-commerce platform. We know when our sports are going to happen. We know how much infrastructure we're going to need if we want to cover them. So we have that means to prepare and schedule resources to be made available and to be spun up by template in advance. And I think to start with, that may be a combination of manual processes by different teams and a set of templates. And I think there's an evolution to bringing that together to define the whole idea of a single, let's have another one of those, click, here it is. I think it'll take time to get to that, and I think you will have periods where maybe it takes a couple of days for everyone to work together and spin up a new one. But then you work on automating those bits once you understand them, and then you can make that happen.
We now seem to be moving from a technology-led business to asking what the business needs and how does the technology actually facilitate that. Would you say that's fair?
Yeah, I think that's absolutely it, because it's no longer about what you can do, but about what you need, and the software can eventually do whatever. Can do whatever you want, but I think it can probably do most things that we're talking about with enough work. I think that certainly the range of applications that you could be using are now such that you can't just sort of go mad and say, well, we want to try everything. I think it then does become much more of a rigorous sorting process where you have to go, well, what do we really need here, and what are our biggest priorities, and what's going to deliver the most value. And especially if you're in the business of developing software, I think you're always doing having this hard discussion all the time about what do we really, what's our real must-haves, and how do we strip away the scope creep, because scope creep within software is it's an incredible challenge, because everyone has so many wonderful ideas, and there are so many directions you can take software in, and I think you have to be very, very focused on where you're going and what you're trying to achieve, and just doing that, and not drifting off scope, because you can waste a huge amount of time and money by implementing the wrong kind of thing. And that's and I haven't even touched on the idea of misunderstandings between what one person is expecting and what the software developer thinks that means.
Software as a profession is making massive inroads into broadcasting. We have to think about the kind of teams we'd build, the people who would be in those teams, the tools they need, the kind of project management they adopt. Agile is relatively new for broadcasters, but it's something that the software community has been using for many years. We have sprints, we have minimum viable products, but all these help with Agile development. And it's really something we must think about more. Software has given us the opportunity to rethink how we do broadcasting. In fact, it's really a massive mindset change about how we think about how we build infrastructures, what it means to build a software infrastructure. You can't touch it, you can't see it, you can't feel it, it's just there. How do we support those infrastructures? How do we build them? How do we maintain them? How do we even specify them? I think deploying IP networks is completely different to the way we used to work in SDI, in a similar way that hardware is different to software, and the way we think about hardware is different to the way we think about software. Because we're moving from static point-to-point systems to highly dynamic, highly scalable, and highly flexible systems. And this again introduces a new mindset change. It enforces a new mindset change. And this became incredibly clear to me when I was talking to Dave Schwarz. I started to ask him about what kind of kit we would buy first. What do you need to buy first when you're building your IP infrastructure? And he surprised me with some of his opinions and views on hybrid.
Well, today there's really no such thing as a fully IP architecture, because there's some equipment that is still only available in SDI, and there's some equipment that is still, that the only reasonable way to do it is SDI for pricing, cheap monitors and the like. So in reality, every IP facility today, whether built on a greenfield or bolt on to an existing facility, is a hybrid. Someday we will be talking about true IP facilities, but we are not there yet, and that's several years away.
I mean, as I understand, obviously designing an IP network is going to be quite different from designing an SDI network. And there are several different types of topologies. Could you tell me a bit more about the different types of topologies and why and where we'd use them?
Well, there's two basic things you can do. Monolithic, which is everything connecting to one switch in your core, and leaf and spine, which is a distributed network. Each one has its appropriate uses. In a small facility, in a single area of a building, it's got, monolith is the only reasonable solution. In a spread out facility geographically or a very large facility, leaf and spine is the way to go, because it's much more extensible and you can put elements all over a campus and trunk back very gracefully. A good example of that would be if you've got a studio campus or a college campus with athletic fields spread around, and that's the easy example. A lot of people gather. You have a control room or a suite of control rooms, galleries in one area, and you can just drop switches and trunk with fiber trunk lines in various other areas and connect cameras, audio systems, whatnot, and they're part and parcel of the core system that way in a leaf spine.
I think one of the interesting aspects of IP networks is that they're scalable and flexible. And with that flexibility comes some interesting challenges about how we think about network bandwidth. Could you tell me how you actually go about calculating network bandwidth in such a dynamic network?
I'm a bit of a stickler on that, in that the place I start in doing any design is not with the network architecture, but I make a rough list of streams in and out, and look at the bandwidth that's actually going to be used. I build it very much like you would start out with an SDI router, where you would calculate, I have so many inputs and so many outputs. So if we start with a calculation of the inputs and outputs, and then start assigning them to different pieces of geography, you can figure out whether you're optimized for leaf and spine, whether monolith makes sense. To zoom out a bit, the real truth of this is that the driving part of the decision is your workflow. It's, it's not just the physical, but it's how you do things, and how you do things defines the streams that you need in and out, which defines your best architecture.
I mean, as I see it, IP networks, or moving to IP networks and IP infrastructures, is a real opportunity to think about how we think about workflows, or reevaluate workflows, or even change workflows. Do you see much evidence of this?
Yes and no. You have to start out with the workflows you know. IP offers the availability to streamline some of your workflows. In other places, you actually have to change the workflow because of some of the changes in IP. But the key here is to start out with what you know. It's a good opportunity to reevaluate your workflows. Do some education. The education is things like, in an IP infrastructure, on your switcher, vision mixer, choose your terminology, everything goes to the router. All your ins, all your outs are attached to the router. In a traditional SDI infrastructure, we might have a camera hit a DA, then go to the router and go to the switcher separately. What this means is that you may want to build your IP infrastructure similarly to what you did, because that works for your workflow with, 100 and some inputs to your switcher. But once you really grasp this, you can streamline. You can say, how many inputs do I use in my biggest show? Well, let's use 150% of that. If I actually use 24 inputs in a show out of the 100 and some that I have wired into the switcher, well, maybe I build the thing out for 36 or 40 inputs, which protects me against doing a bigger show running out. But since everything's on the router, you actually have whatever streams, whatever sources you have on the router are behind the switcher. Everything is effectively into the switcher. And if you attach them for control, then you can have 80 buttons on the switcher, only 40 inputs, and those buttons can call things from the router that aren't currently in the switcher. So you can make the switcher operationally the same size you were, but have a lot less I/O that you're paying for.
Okay.
But it takes people a while often to get their heads around that. And to get a comfort factor with that kind of integration. So some people are doing that, others aren't. That's that's where we would define where workflow. If you choose to do it that way, that defines a certain set of inputs, a certain amount of bandwidth. If you choose not to, if you choose to do it the traditional way, then you need more bandwidth, more switch, more interfaces, etc.
We hear a lot about non-blocking switches, and as I can see, that seems something to be quite new, and they seem to be a bit of a hot topic at the moment. Could you tell me a bit more about non-blocking switches and why I would use them and where?
It's what we've been doing for the last 5 years. Well, let's start off with blocking, and there's no such thing as blocking and non-blocking switches used in a broadcast IP environment. It's the architecture that's blocking or non-blocking. In anything that I've been involved in the design of, the switches themselves are all the backplane of the switch is wire speed. So if you have 48 ports at 10 gigs, the backplane can do 960 gigs, 10 gigs in, 10 gigs out on every port. So the switch itself is non-blocking. It depends on how you interconnect the switches, whether you're blocking or not. So the definition of blocking and non-blocking here is really what we should talk about. A non-blocking architecture means that a destination on this switch, or every destination on this switch, can take sources from every switch that's out here through the core. You've got enough bandwidth for nothing to be locally switched on this switch. Everything is coming in from elsewhere. Now, that's the way, frankly, every facility I've built so far has been. That's been the thought process that we've been working on with IP. It's not as, and that actually represents a change from where we were, because it wasn't uncommon to have a core SDI router and then, a large core SDI router in a facility, and then smaller routers centered around control rooms or other parts of the facility. And then we had a fixed number of tie lines between them. Now, if you take that as a pure workflow, that versus the IP, that's a blocking workflow. And we were okay with that. Now, if you want to spend the money on a non-blocking workflow, that's fine if that's what's required. But in a lot of situations, it's almost a buzzword. You don't need to do that. If you can assign enough bandwidth to those trunks between the switches so that you've got everything you can imagine you need plus a 50% overhead, you've got a lot more connectivity than you had in that SDI router to router with maybe 12 tie lines in each direction. You could put 100 tie lines logically on the IP system, but still save a lot of money on your core switches, your fiber infrastructure, your SFPs. This comes back to the workflow discussion. If we understand the workflow, we can optimize the system for the workflow so that there's a load of headroom. You're not going to run up against the ceiling, but you can do it for the minimum amount of money. If we don't understand the workflow, if you can't define your workflow, then the only reasonable choice is to build non-blocking, because that way, as you redefine your workflows in the IP environment, you're completely safe. You can't run into a problem. But we didn't have non-blocking before. We don't necessarily need to be non-blocking now. It's just from a technical perspective, with people not grasping the potential changes in the workflow, it's the path of least resistance intellectually.
Yeah. Understanding workflows is key to designing efficient IP infrastructures. As Dave reminds us, it's the architecture that causes the blocks and not necessarily the switches. But this is nothing new. We've seen this for many years with SDI infrastructures. For example, if you have a central router and you want to build a facility, expand and build a facility extra to that, so maybe you want to build a graphics area or a studio, then that would need its own router. You would have to connect that router back to the central router somehow. The standard way of doing this is to use tie lines, but every input to the central router requires an output from your studio router and vice versa. So we have a natural limit to the number of tie lines we can link between the two. And the same is true for IP architectures. Thank you for watching the first in our series of transitioning to broadcast IP infrastructures. In part 2, we're going to take a much deeper look into architectures and the challenges that we need to overcome them.